Future for Masters in Environmental Science, MPECs. Start with just a quick history of what's going on with environmental masters at SEAS. We own MPEC, Masters Pollution Environmental Control. It's the longest running sort of pollution environmental related MSc in the UK. Did recruit very strongly until 1990, but at that point Research Council no longer funded the Masters. It had previously had the highest number of funded places anywhere, but once the funding wasn't available, then there's a massive drop in recruitment. We were kept going really by the MPEC programme, which is a 2-year environmental Masters that put together with some partners in Europe. It's an Erasmus Mundus programme, and that's delivered us anywhere between 8 and 13 students a year, and it continues to do that. We've got second and third rounds of funding for that. However, the big change has come about recently. In 2014, we got 4 Chinese students, 16 in 2015, 34 in 2016. So basically, we got discovered by China. We had a secondary course running as well, which doesn't run anymore, Maze, but that also had Chinese students on it. So altogether, anyway, we've got a huge increase in the amount of students on the programme. 2017-18, we had 50 in the class, and this year, 2018-19, we've got 76. So from sort of over the last 5 years, we've gone from about 8 or 9 students to 76. Current structure, there's a Semester 1 Environmental Science core and 1 optional unit. And then Semester 2, there's a wide range of options chosen from courses within the school. And then third semester, there's a 60 credit project. The MESBOM students come in after doing 1 year already at Central European University in Budapest. The generic core is the measuring and predicting module. It's a big module, 30 credits, research methods, but focused particularly on environmental science, the processes and techniques for environmental science research. There's a tutorial and workshop module, which is compulsory, second semester, and there's a subject-specific unit, which is effectively compulsory in first semester, which is environmental consultancy. Really what we have is an opportunity. This enormous bulge of Chinese students probably won't last forever, but maybe for the next 5 years. But this is the opportunity to make hay while the sun shines and to actually make the course sustainable. At the moment, it's doing a very good job of filling a gap in the undergraduate recruitment market, and also it's ironing out this cyclical recruitment we get on the petroleum MSc, which has had very large numbers in the past, but has now got only 20 on. So really we should take this opportunity to strengthen the MPEC course. It's not been invested in since it began, but now would be a good opportunity. In order to be sustainable, we've got to attract students other than the Chinese students, because when the Chinese students go away, we need to have a solid course that's left. The only reliable way of achieving this, there's no shortcuts. We need to raise and maintain the quality of the course. We need to address that seriously. And longer term, we've got to ensure the employers are aware of that quality and ensure students are aware that employers value the course. That's the cycle that we need to get into. It's a long-term thing, but we do have an opportunity to start doing that now because of this bulge of Chinese students. To do that, we need to address the quality and the relevance of the course. The course content should be designed by a staff team working with employers. It should be specific to the MSc only and specific to the skills of this school. Currently that isn't the case. We're living with a hangover of past courses that aren't MSc specific. They take from undergraduate units and they also take from outside the school. For the relevance, we need to have stronger links to industry, both through projects but also internships and ultimately employment, and get returnees from employment to come back to the course to talk to the students. So design the course for purpose. It was designed in 1976 for traditional single honours degree students because there was no environmental science as a subject then, and it was a transfer course, transfer skills into employment in environmental science. It had a clear purpose, and that generated a clear structure. The content was related to 3 equally weighted themes: pollution damage, public authority control and technical control. All the modules were specific to MPEC. So there's 20 years of success with that model. No variations within it. This is what was being taught, and it had a specific purpose. But environmental science has matured, and that's become more specialised, and our course structure really has degenerated because staff have left, and there hasn't been resource put into the course because there haven't been many students on it. So we need to design by supply and not demand. Demand actually was small, but we need to actually come up with something that people want to do. As student numbers have fell, MPEC became designed by availability of course units rather than by demands of the employment market. Just whatever was available is what we've used. At its lowest, or cheapest point, it was wholly composed of modules delivered to other students at third year level. So really that cost us nothing to run the course, well, apart from the time of someone to manage it. In 2012, first semester specific to Masters in Environmental Science was implemented, and that was this measuring and predicting course that was specific for them, 30 credits. The Chinese Bowls reproduces the mid-70s opportunity to design a course. The programme should be designed by a team of contributing staff collaborating with industry. The modules should be solely for the MSc level, not third year plus, just for MSc. It's a particular thing, it's an applied course, and it all needs to be related to application. They should be run within Cs, but can and should be offered to students outside Cs. This will ensure we have ownership of the course by the employers and the staff, critically, that teach it, and also the students. At the same time, that would maximise FTE income. Up till now, it's been somewhat unloved, and ownership's critical really to success. And that's ownership by staff, students and employers. And no one wants to own anything that they haven't been involved in designing. The overall purpose is to prepare students for a career in research or as environmental officers in industry, environmental consultancy or regulation. The course should be recognised internationally and thereby attracting self-sustaining numbers of students and further collaborative research with industrial partners. I think at programme level ILO should be separating signal and noise in environmental systems. Separating signal and noise, so it's dealing with data. These are the most general sorts of concepts, the things that employers want that can be of general use. The projects the employers do vary from day to day and week to week, but they need skills, and these generic skills are what they need. The coherence of the programme arises from all the modules being built around and referring to this concept. And the modules must be built around data analysis, design of investigations and communication. The specific data that's being analysed, the specific investigation, is less important because, as I say, for most employers, the subject, the object of their research changes from day to day and week to week, but it must be built around. We must build our course around skills. So the original bespoke 3-component MPEC could be reproduced, but with different components. It suggests having a data, an instrumentation, and a practice component. Data effectively predicting from the measure and predicting module, and there's particular targets that we should be reaching in that, which are listed there. That's not exhaustive, but these are targets that we should be aiming for, and there's various things along the way to reaching the teaching of these things that are very important objectives in themselves. In instrumentation, the usual things we expect about knowing about analytical techniques, but a new thing would be the design of a monitoring instrument, and that would be built around an Arduino, so doing some microcontroller coding. Coding would also feature obviously in the data part of the data component as well. It would be central really to all of these aspects. And then the practice would be somewhere we'd be getting a lot of involvement from industry, And the particular things, again, not exhaustive, but the particular things would be training to do phase 1 and phase 2 habitat surveys and phase 1 and phase 2 site investigations. Try and unify the whole lot by having a particular case study or field site that we could keep referring to, where we could collect data from and we could visit. So we'd have that site instrumented, and there's a lot to be learned from the instrumentation process itself and the maintenance of the instruments, but it would also mean that we'd be collecting high spatiotemporal resolution data, which we could be using and manipulating in the data module. Most likely, we could do this following a water course from east to west, which is basically going from clean water from the east to dirty water after it's passed through Manchester. And there's a whole load of things we can look at as we move through that catchment. We have permission at the moment to work in Crowden Great Brook, and we have a partly instrumented catchment there. We move into the Mersey Valley, which is already used by ecologists in seas for the area west of Manchester and for doing ecological survey work. The second part of this, the relevance, is making our links to industry. And the external examiner, to which we should really pay most attention, is less the academic that comes along and more the industrial partners. Resources should be available for developing and maintaining these links, and we'll talk about that more in the resources section. Primarily, Masters in Environmental Science delivered by University of Manchester staff, because we need the FTEs, but because the course is primarily an education, not a training. Training is critical because it's an applied course, but we deliver the education. Education should be achieved via application to problems faced by industry, but aspects of the training are best delivered by industry. We can't get away from that. People that do this day to day, they're much better at delivering the training, and we need to get them involved in the course. There's multiple reasons why that's beneficial. Distance learning is actually something as well that we can use. It's a connection to industry. Employers and employees in the environmental sector should be an important constituency for Masters in Environmental Science. Employers would be prepared to fund employees to actually come and do the MSc because it increases the skills to MSc level, brings the latest research into their clients' projects and the latest research into their business. All that's possible if the employees can do this as distance learning, so they're not away from the office and they can continue doing their work as much as possible. On that basis, employers might well be prepared to pay the fees. It also brings the employers much more into our orbit, which is important for several reasons. We can maximise the return on our teaching effort if we design a course for distance learning, but also make the same course available for both distance and on-campus study, effectively the same course. On campus, we'd have the method of delivery as online content and podcasting, but we would have contact time, but we'd use that contact time very efficiently and effectively. We'd have minimal lecture time, but in those lectures we'd motivate the students and direct them through the online material, not take them through it, but motivate them to do it. We'd have high quality tutorial time in smaller groups, and then maybe run practical drop-in sessions, which could be run by teaching assistants. There would be field trips, which would include team working in preparation, commission and reporting, and then ultimately a large chunk of contact time on project supervision. Off campus, again, online content and podcasting. Some of the team working and motivation can be through various functions on Blackboard, through the bulletin board aspects and blogs. There's ways of managing that. And the field work, we would produce some video content that the student could look at. Projects are one of the problems because they don't scale. We can throw more people into a lecture and it's not a problem, but projects, it seems inevitable there has to be some one-to-one work, and that would be the case. But generally the projects would be more data focused. All of them would include some coding as a partial replacement for laboratory and field work, only partial. There'd still be room for many places for laboratory and field work, but all projects would have some coding in, and that would actually be something the students can work away on their own at and be easily advised online as well. In-work projects will also be something that would be used. So those people doing it at distance could be doing their project as part of the project they're working on for their employer. This is typical in consultancy, but the project could be used in a slightly different way and used as a basis for an MSc thesis. They'll obviously need an academic supervisor to ensure that that was the case, but that would work very well for employers. Resource requirements. Currently, there's a module measuring predicting, which is similar to the specification of the new MPEC, but it's only 30 credits and we need to expand to 80. Currently there's 6 staff involved, but really this should reduce to just 3 for continuity and integration. I think the small team of staff delivering the course is critical really to its success and ownership. That's ownership by the staff, but also ownership by the students. Too many faces does not work. Current environmental consultancy module is similar to the pros and practice component, but that would also have to expand, including some ecological work. Core staff would want, but with industrial inputs. That would be a major place for industrial input. All core staff, I think, should deliver 90% of MPEC. Sabbatical time is necessary to develop the course material, and we need to get an instrumented catchment sorted out. Practitioners must teach on this as an applied course. It's necessary. Industrial experience is limited amongst academic staff because that's not what we do. Senior practitioners are much more effective and efficient in making contributions to this kind of applied course. Involvement of the practitioners, though, can't be done as a favour. That's not acceptable in the quality assurance we need for this kind of course. For this critical input to be reliable, and that means timetableable, immovably timetable, 12 months in advance, and to meet the University of Manchester requirements, these people need to be on the staff, part-time, or at least remunerated at a proper level, but I think a part-time position. There's many consultants, we know senior consultants that would be keen to do this. So how to progress? Critical to progress and delivery is money. We need to buy out staff time to develop new modules, and then we need to have 4 staff that are dedicated to design and delivery of the taught component of the programme. I think the best way to proceed with this is to advertise these positions within Cs. We want people that want to do this and see this as something that's valuable to them going forward for their career, which it should be. Ultimately, if we can work this out and deliver it properly, then it should free up a lot of time for those staff to do their research, which should be very closely connected to the course. Potentially, the revised programme could start in September 2020.